Welcome to Tech at Lunch, the podcast that satisfies your hunger for all things tech while you enjoy your midday meal. So grab your sandwich, tune in, and let's dig in. Hello, I'm Nick.
Hello, I'm Ed.
And you can kind of hear we got Ed back. You know, we've had a little bit of some stuff going on lately. So, we kind of been bouncing around a little bit. Sorry we didn't get one in last week. It's been one of those days. But I do want to kind of go back before we kind of get into this week's topic. And, I want to, bring to Ed's attention kind of when I did my one-on-one with y'all, we talked about something called STEM risk. It's understanding the risk of what you're getting ready to go into, taking the risk to go learn something new, to pursue a new education, which you've done, to pursue something where you want to learn STEM, right? What are you thinking when you start hearing STEM risk?
Well, for me, I think the big thing to do is when you're talking about risk, maybe risk is one way of saying it, or maybe you can say, trying new things. Mm-hmm. So if you don't do experimentation. So I would say it's more like experimenting.
Right.
So if some of the giants that came before us with some of the science phenomena that we didn't know about, prior to the 1900s. If those guys hadn't did the experimentation, if those guys had not tried things, took risk, maybe did things that was outside of the norm of what we understood for science, it's the same thing with STEM. Mm-hmm. So I think STEM is just a platform to get those ideals, from when we were kids watching Star Trek and Star Wars and Buck Rogers and all these type of shows, where we was like, wow, this would be awesome if this could happen, to now it's happening. I mean, who don't realize the correlation between Star Trek and the flip phone?
Right. Communicator.
I mean, things that I saw as a kid is happening now in real time. Mm-hmm. Things like, hey, we might be able to go to Mars too. We will go to Mars.
Yeah, it's not if, it's when.
And I think that's part of that STEM risk.
Okay. Yep. A lot of understanding the risk acceptance also, I think, is a really big one. And you cover really good points, especially when it comes down to stuff that we didn't think was plausible and now guess what's possible. I grew up with a grandfather of the Apollo era, the Mercury era, and all of that, who played a very large role, and eventually we'll probably go into some NASA stuff eventually. But it's really who spearhead a lot of the efforts in what we call space flight today, especially in propulsion. However, it's and especially aviation and stuff like that. But still, back in those days, we were still dealing with a mere space station. We didn't have the International Space Station yet. We were building it. We were slowly but surely sending up the space shuttle. And for me, a kid growing up in Florida, you're kind of surrounded by STEM. You're surrounded by being able to walk in your backyard and have the luxury of watching a space shuttle fly over your head. You would watch the countdown on TV, and I still remember we watched the countdown on the tube TV, and we go run out back because you could look up, and my dad would point us in the right direction, and you see it flying over your head, and it was that or watching them shoot the regular rockets in the orbit, delivering satellites and payloads and stuff like that. So that's when you start getting that risk acceptance. And the thing is it's risk balance, I guess you could say, but. Like you said, it's trying something that we haven't done before that now we're making a reality. Because somebody goes, "Oh, that sounds kind of cool."
Yeah, I can remember.
Who would have thought the communicator would turn to the new age Nextel?
Yeah. Well, I remember back when I'll just give two examples of what we're using in STEM now. Mm-hmm. That I remember when I was a kid, like. I remember back as a kid, as far as a microcontroller was concerned, you were programming that in assembly language.
Yeah.
Or C.
Yep.
Or C++. I mean, now you got languages like Python
and
that
Perl,
makes
R.
it easier as an entry point for people to
Yep.
do. You know, you can still use C and C++ and something like
Right.
Raspberry Pi. You can use, but to be able to use Python for a kid and be able to do a blink test, like blink a LED.
Yeah.
I mean, back then, for us to do something like that, it wasn't one board. You had to
Yeah.
build a board. The board didn't exist.
Right.
It was a breadboard. You put the components through the breadboard. You would run wire and solder everything together
Yep.
on a breadboard and figure this stuff out by yourself.
Yep.
There was no internet back then.
You-
You had
you-
to read data sheets. You had to go into Radio Shack and figure out what components you had to have and all this kind of stuff. I mean, it's amazing
Yeah.
what the kids have today compared to what I had when I was a kid.
I didn't grow up with very late, and growing up, did we ever have our first computer in the house? So I remember very vividly, that's why I kind of chuckle when you say Radio Shack. I still remember going up to the local Radio Shack was less than a mile and a half from my house, right? It was up next to Publix, and we go in and we would peruse the Radio Shack, and we would look through there and look for stuff we needed, stuff to build. This is when the Nokia, remember the gray Nokia with a big battery on it, little flimsy ass antenna that you'd open up and you think you'd break it? The original flip phones, which we didn't have one of those. We were still worrying about bag phones and shit.
Yep, had those.
But
Pagers.
Yep. But the thing is, and then we started going to Nextel. But we would go up there and we'd look, see what we needed, how we wanted to build, and who we wanted to tinker with. Because we all had to fix something. Because it was cheaper than going to Home Depot, but made more sense than going to someplace else. Like for us, we also had electronic recycling stores in Orlando that we could go to, and you could buy entire PLCs and stuff there because that's what they had, right? But everybody got so excited when the mall opened, the town mall opened. It's supposed to be the gathering place for the town. Shows how small my hometown is, but everybody got excited because of the size of the Radio Shack. The Radio Shack was supposed to be huge, and everybody could go in there and find what they wanted. That's also back when they had the video games at the FYE, and we could go in there and listen to records and stuff, and CDs before you bought them, because that's what you had to do back then. You didn't know if you liked the CD or not until you scanned it and you get to listen to a couple tracks on it, because guess what? We didn't have XM radio at that time.
No. I mean, like I say, I grew up in a time of, LPs and 45s and, cassette tapes and stuff like that. But the other thing I remember, so the first PC I had was a clone of a Commodore 64. And I think after that we went to a Tandy-based computer from Radio Shack. And, you moved up. We finally got a Microsoft clone. Wasn't the actual Microsoft.
Yeah, no.
But I just remember programming stuff in BASIC, where you was using GoTo to actually do your loops and so forth. And so that's what I mean by STEM today. the things that they can do in real time and the chance that the opportunities they have to make discoveries is way. They're really fortunate now.
Yeah, and it's like back then, once we started getting the computers, we had I think we had a compact Basario. Remember the colored ones?
Yeah.
Like
I said, that's the clones of the Microsoft PCs, the IBM.
Yeah, the IBM. Yeah. The Apple knockoffs. And with Windows NT and 95 on it, and good lord.
Try 3.1.
Yeah, I've done that, been there, done that. I remember playing on DOS. Just to say, you could still not make it through very far in Oregon Trail, even in DOS. But, and where your internet came in the mail because it's the only time you got free AOL.
AOL
And then Netscape.
Yeah.
Because there were two competing brands before Netscape became a browser.
Yeah.
But, and the thing is I think that also does lead us into what we kind of want to talk about this week. Is STEM change based on industry need? You know, if we look at the different industries that we deal with on a daily basis, or on a routine basis, for that matter, as the STEM has changed, STEM is always going to be basic science, technology, engineering, and math. However, its application is going to change. So you can really look at the STEM application per industry. It's always going to adjust itself based on industrial need, growth, and shrink. We're always going to play that game. We're going to play the long game.
So it should be STEM AI.
Yeah.
So
Ish.
no, so the regular STEM.
Yeah.
The art that they're adding now with STEM.
Right.
And industrial.
Yeah. I think so. State. But I can see that. And, right now they also call it STEAM, where they add the A in there. However you can call it STEAMY. If you wanted to add the I and the E, and somebody out there, you got some language arts nerd going, that's not how you spell STEAMY. Yeah, we know.
But like I said, the art part of it is, when we say art,
yeah,
the application is, like we were saying, adjusting.
Yeah, exactly.
So there are people that like dashboards.
Yep.
Or what we call visual management.
Mm-hmm.
That is an example of where you can use STEM to educate people into how to use those type of things to do this visual management, wherever and however you're using it.
Right. And the thing is when I start hearing art and I start adding it, with its other friends, make it a complete circle, make a complete package. When I start hearing art, especially since I have art, and especially when I look at STEAM, how it's spelled, STEAM, I have the A is really close to E, at that point. Mm-hmm. So you start dealing with AutoCAD. You start dealing with, engineering-based art. You're dealing with the world of path planning. Because these guys understand what that art's supposed to look like at the end of the day. You guys who are drawing out cut routes for plasma tables, for water jets.
And I think some of that is I think that kind of fall of engineering and the industrialized part of it. Now
so could we can call it now, because now I'm following what you're kind of an idea off of what you're saying. So could we call it industrial art?
Yeah, I mean, because like the engineering,
yeah,
all of that goes into your CAD,
right?
Your CAM, your simulation software, your virtual augmentation.
Yeah,
all of those things are tools that work in there, and yet it could be a subset, like you're saying, of the A.
Right.
So the A has two sides of it. The A has a commercial application. And the A has a industrial or a space or whatever problem you're trying to solve.
Right.
And that's part of the adjustment you're talking about. Yeah. It depends on what the industry needs.
And the thing is this is where I'm going to throw in, one of our little friends, not John, but 3D printing. Mm-hmm. If you kind of think about where that falls across STEAM now, or STEM, however you want to look at it, however you think about it, it kind of, I guess, it hits all the major wickets. Mm-hmm. However, you start dealing with STL design, stuff like that. So now you're combining engineering and art again. Mm-hmm. But then you have the creation, which falls on the technology side of the house, which is still involved. It's an engineering technology. It always has been, always will be. I don't really care what people think. Because it's what it is. Now, but the thing is people are using it for art, which is great, and I hope they keep doing it that way. But it started out as engineering technology. Yeah. So,
yes, I think
it falls in a weird spot.
So you have to,
some of its parts at least.
When we say art, it's a couple of ways to look at when people say art. Mm-hmm. So when we're talking about art, we're not so much talking about someone sitting down drawing in a sketch pad and drawing the cathedral at Notre Dame.
Right.
What we're talking about is any artisan or any skilled person or anybody that's been doing something at some point, it becomes an art.
Right.
You cannot teach that. That's that
True.
person's technique. Mm-hmm. That's that person's way of doing things. Like people that know how to, just a sidebar, and then we're only gonna go for a second. But people that know how to grill whole hog, they know how to grill whole hog for a reason.
Yeah.
It's yes, they can use technology, but the technology doesn't have the art of they know, hey, at this time, this smell, this heat, they know when to go check it. It's the same thing when a person paints
Right.
a piece of art. It's a skill. It's the same thing when a person welds.
Yep.
It's a skill. It's muscle memory. But that skill has to be developed. So when a person goes into CAD, CAM, and enter these virtual augmentation or simulation, that is an art. It's a
I agree
skill
with you.
that you have to get to, but it becomes an art.
And if you think about it, the guys and the thing is I really hope this does reach some of those people, is the architecture people, the architects. Those guys or gals, whomever, God forbid these days.
We gonna stick with the first two.
Yeah.
We
Whomever.
we're from a certain generation, so we're not going to conform. There we go.
Yeah.
All right, let's move on.
There we go. Glad we're getting our words out now.
Yeah.
Might have been here a while if we get it. However, the thing is those individuals probably are that level of where, hey, let me design this via computer, but let me also design this on paper. You know, it's especially the guys that, or gals or whoever, folks who are building bridges, industrial architects, building buildings and stuff, understanding load balancing.
Civil engineering.
Civil engineering, yep. We got a couple of those guys where we work. And y'all, if y'all are part of civil engineering, y'all are some weird ducks. I'm just going to throw that out there.
And they also build models.
Yeah.
They don't just draw something out.
Right. And the thing is they have some really cool tools.
Yeah.
Like a 2x4 and an air cannon that they're going to launch at, at hurricane speeds to see what happens.
I mean,
I play with it?
they have places where they build model
Yeah.
boats, and they'll put it in a tank where they can simulate the waves that
Yep.
would see.
Yeah, naval architects, yeah.
And then they can take some measurements, and then they can feed that back into it and say, well, what did this affect?
Yeah.
So I mean, like it's that's the art.
Yep.
That's the art
And
that we're talking about.
There's a speaking of wave programs, I've been wanting to try to get a hold of one of my old professors at Penn State who is actually part of that wave program, and they have an entire wave room that they have it calculated based on ship, drone, or whatever size, depending on what they're working on, because it is part of DARPA, or supported by, but or by, it's actually NAVWAR. But the thing is that type of stuff, they can tune it to see exactly what each wave size is going to do against what hull design. So, the naval architects, it's not a naval school by any stretch of the imagination. You're landlocked Pennsylvania. The closest thing you see to a lake is freaking, Lake Superior, which is a couple miles away. But, or the puddle next door. But the thing is so these guys are actually building these models. And the thing is, it's not just our school. The Naval Academy has one too, where they're doing naval architecture and they're testing these models based off of size. It's cool. But then you start getting into the guys who are doing airfoil design for lift, drag, wing design and stuff like that.
Yeah.
And then you kind of
they do use wind tunnels too.
Yeah.
They do some of the same, especially with the wings, the wind coils and stuff.
and but that's also when you start getting into the really cool shit. It's you get the guys who are involved in Formula One or IndyCar.
Once again, that's a science. Somebody
Right.
they come up with a design. Somebody is hand building some of those models.
Right.
They're still doing this stuff by hand with clay.
Yeah, they're still doing it the old school way. And if you think about the engineering behind the aerodynamics, so now you have engineers who have to speak art.
Yeah.
You also have the artists who have to speak engineering and technology, the math folks. Some people are doing the clay cutting with a CNC machine, while others kind of know the look and feel. It depends on generation, I guess. But the thing is all of these machines are ran through digital at that point before they're even thrown onto a wind tunnel, a digital wind tunnel to kind of see what's going to happen.
Right.
If you start thinking about it, when you start dealing with downforce and drag design of a rear wing on a race car or a street car, for that matter, you got to think about, even your little bit of downforce can produce hundreds of pounds of downforce in the front tires, and or on the hood of your car if you don't have it secured right and it punctures a couple holes. But if it's chassis mounted, all that weight is now going down to the front nose of that vehicle. Too much downforce, you're dragging the nose across the ground.
But
at certain speeds.
By looking at nature,
yeah.
Once again, this is an art.
Yep.
Most of the natural phenomena is how we've made advances in science.
Yep.
They've looked at what nature does, and then they've either mimicked it, understood what it was doing, and adapted it back to, here's how you make the change, or you pivot.
Right.
You pivot with the technology. So where we were doing by hand with clay, 5 to 10 years from now, we'll be doing it with 3D printing.
Right, exactly. I can see that.
I mean,
houses already being done that way.
But you'll be able to quickly print out something, in carbon fiber, put it on whatever you're trying to test, see what it does, take the measurements, because now we're going to be using IoT or IoT, using MQTT, taking all this data, pulling these points, actually letting machine learning and AI do some of the manual stuff, and then we'll make an interpretation. Oh, that didn't work. So we'll become Tony Stark.
I was reading an article one day, and it was talking about the data points on a F1 car and on an Indy car and stuff like that. You're talking terabytes of data during a race that are being fed back from its onboard sensors and sensor, collection programs back to its home base on the track. So in real time, your on-site engineers can look at, transmission temperatures, motor temperatures, water temperatures, brake temperatures, drag and downforce.
Most important? What's the most important? What's the thing that is the most important in any type of racing event you've ever watched?
The driver.
That's secondary, and that's an art.
Yeah.
I'm saying sticking with what you're talking about, onboard sensors.
Yeah.
The tires.
Right.
What happens when the tires, they're smart?
Yeah.
Somewhat. But what happens when that intelligence grows in the tires?
And the thing is a lot of times you start seeing the sensor that they were showing is a slip sensor. So showing how bad that suspension's slipping off of its intended track. So it's actually seeing, am I getting too much wear in my tires? Because they don't have wear sensors on the tires, and they can't run TPMS. So they have to, yet. But they have to run the wear, the drift sensors, I guess you could call them. And to me, it's like, the amount of sensors that we're putting into these cars is absolutely crazy. And
and the brains that's on board to be able to help with that processing, because that would be a enormous task to try to pull that data without having something that can pre-process it before it goes to the next spot.
And the thing is, even in your street car, like for example, I'm going to hopefully be building a budget car here soon, budget secondary, for Hot Rod Power Tour for me and my dad to go. And part of that experiment, I guess you could say, is not just to bring people, awareness of who we are, in the company that we have, but it's also to take some design stuff as far as if you read Hot Rod Magazine, you'll understand the 3D printing, 3D scanning, and data collection stuff, and incorporate that into a car that's now going to go travel 3,000 miles. And actually kind of see what that process is. It's seeing how 3D printing is working on it. How it's surviving time and time again to see if you have to do material adjustments and stuff like that. It's a test bed. It's a daily driven test bed. And the thing is for me, it's going to get kind of interesting. Because something breaks, guess what? Who has to fix it? But the thing is most of your new ECUs that you have on board can take all the sensor data and kind of tell you exactly what's going on. For example, you got the clutch sensors, you have freaking brake sensors, you have all these other sensors for these cars to kind of tell you exactly what's going on. So, and yes, the vehicle will be a manual. But the thing is, as you move forward in that type of environment, things change, things advance. But most of your on-car stuff all came from racing. All came from there. Where did the onboard wing come from? Came from any of those companies. Or good brakes came from the need of the land speed guys, because you're trying to stop a 200-mile-an-hour car, with a parachute and a pair of brakes.
Yeah.
And back in the day, it was just brakes.
I think that the thing that I'm most interested in is when we're talking about, adjusting to the needs, when we're talking about STEM. So those are some of the things, but I'm looking forward to the day when the manufacturing industry comes around and decides, hey, if it works in an automobile, why couldn't it work in a machine?
Yeah, I
The
agree with that.
machine should have that type of connectivity. I'm not saying we have to add 1 million sensors.
Mm-hmm.
We don't even have to change the sensors we have out in the field.
Right.
We just change the devices that are looking at the signals. Let the device determine what's going on with the sensor.
Like a modernized dress pack.
Well, I mean, like there are several distributed I/O or remote I/O packages out there now,
Right.
that support MQTT.
Mm-hmm.
So what I'm saying is, you should harness
Oh yeah.
that data or harvest that data. But when you're harvesting that data, you can't. Okay, let's get one. This is not a cereal bowl or a cereal dispenser machine. That's not how data works.
No.
Data is not information.
No.
Data is an event
Right.
that gives you a time that you can correlate with something else
To an action.
to get information.
Yeah.
So what that means is we're not polling. It's over with. We're done with serial and old parallel communicating. We need to think about, how we deal with data differently.
Mm-hmm.
So I don't want to poll something 1 million times that has nothing to do with what's going on.
Right.
I only care about if, for example, I have a temperature sensor that says, hey, if I go below 7 degrees C, or if I go above 9 degrees C, hey, that's an event.
Yeah. Throw a warning.
It goes to a unified namespace or whatever you want to use for the OPCU guys. Which is inefficient. So you would go to a unified namespace. You would get only the data you're requesting.
Mm-hmm.
Now what that means is now the guy that thought his job was going to be replaced, because the machine is smart enough now to do most of the normal troubleshooting that a technician would do. So the reset technicians would go away, and we would end up with data analysts that know, or subject matter experts that can do data analysis on the equipment that they have gained an art at maintaining.
So the day of push button maintenance is gone.
Yes.
Thank God. We can only hope for that day to happen. And you got to think about it, guys. As we're talking about things, as we bring things up, we are part of the how it's made generation. When kids want to learn how something was put together and the only thing they had on TV was Discovery Channel, you get how it's made.
A Junkyard War.
Junkyard Wars, yep. Stuff like that.
Right up your alley. If
Oh,
you're a
dude,
hot
I love
rod
it.
guy.
I loved it. Still do. I still go back and watch the old ones just because I think it's hilarious.
What was it with Jesse James?
Monster Garage.
Monster Garage.
Yep. Still another fun one. But the thing is you cannot play the theme song to how it's made and not know what it is.
Yep.
You immediately know. But the thing is that curiosity and that drive needs to come back. A lot of creators in the creator space have done very, 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 very well with pushing the STEM envelope on platforms like YouTube, platforms like TikTok. I've posted a lot of stuff lately on STEM Legends and stuff like that. I try to do one every couple days, for everybody to kind of learn something new about a different person. But there are some people who are taking it a whole other level. They're teaching entire courses, and the guys who are teaching on Udemy, Skillshare, and that type of stuff. But the thing is I mean, this is where it's one of those type of environments of as this happens, people learn more. However, I think there will be, and that I think is the STEM change when it comes down to the entertainment industry. We've moved a lot of stuff over to YouTube or streaming services and stuff like that. And there is definitely a need to bring back shows like, not just like Monster Garage or, Junkyard Wars. Junkyard Wars would be a good one to bring back, actually. Especially with the amount of junk that's in the junkyards these days. God knows what people would build. But bring back STEM and manufacturing shows that shows kids how things are made. Bring back how it's made. Bring back that type of show that really gets kids interested in what is STEM education. Show the next generation of, hey, this is what 3D printing is. And do a show on STEM. Mythbusters. You can't really bring them back. They don't agree on jack
Can't
squat.
bring them back, but I was saying this.
Yeah, right.
So all these shows.
Yeah.
So I had.
But Mythbusters, I definitely think something like that needs to come back.
So we had different shows when we were young that
Yeah.
did different stuff with science type things.
Yeah.
What I'm saying is we say, how does STEM adjust?
Yeah.
STEM should adjust to today.
Yeah.
So it should be shows based on what the pioneers did, but with a different view, because
Right.
it's not the same. It's not the same thing that we had when we were a kid, because we were Star Trek and Star Wars.
Right.
These kids now, like Elon Musk and
Right.
Mars, and we have man-made devices that have left our universe.
Well, yeah.
Or, excuse me, our galaxy. Not
Our
our
galaxy,
universe, our
yes.
galaxy.
Galaxy.
Sorry, I stand correct.
But the thing is, if y'all don't know what that is, please go look. Not the galaxy, but what left. But Voyager 1 and 2.
Yeah.
They're out there, flying behind themselves. Like we
And
just
this
had
is in the 70s, man.
right. We just launched Europa Clipper.
Yep.
Big mission day before yesterday, on on Falcon Heavy.
Rovers,
yeah.
Mars rovers, all the things with the
helicopters,
drones,
yeah.
the helicopters, all the things that they've done at Mars. I mean, groundbreaking.
Yeah, and the thing is the reason why I brought up Europa Clipper, and also the new James Webb Telescope, but Europa Clipper is heading to Venus's moon, Europa, and it is one of the it's like the gaseous giant that they believe there might be water, down underneath it. However, most of its atmosphere is all carbon monoxide. Mm-hmm. So we'll see what happens.
Well, like they were talking, and not to get all off into space, we will eventually do one where we talk about some of the things with space from a perspective when we were kids to now. But don't forget about Jupiter and its moons.
Yeah.
And the potential for some of those moons, and some of the Earth-like planets and exoplanets they found.
Yep. And I'm double checking to make sure that I'm actually sending something to where it's going to a Galilean moon. Wow, spell that one freaking 5 times. Saw that one 5 times fast. But the thing is, it's on its way. It's one of Jupiter's moons. So hopefully we'll see it arrive in the next 6 months. It's kind of rocketing that way, But the thing is, we just now saw SpaceX actually catch one of their Falcon Heavies. Not Falcon Heavy, but Starship, the booster. But the thing is, and also do a controlled landing of of their of Starship, downrange in the Indian Ocean. But the thing is, this stuff would not have ever been thought about back in the day, ever.
Well, if Elon, like Tesla, like Edison, like Maybe not Edison so much. Einstein, you know, like Galileo and all these guys back then, Copernicus and some of these guys back from there. If they hadn't have been curious, if they hadn't have pivoted, if they hadn't have adjusted their stem, if I may, to what was going on then we wouldn't have SpaceX.
Right, exactly.
And what I'm excited about SpaceX is not catching a rocket, not landing. That's not the thing I'm excited about. The thing I'm excited about is no one that's a bureaucrat is messing up people trying to develop the technology.
Right.
That's what I'm excited about. The people that are the brains are in control of what happens with that technology.
Yep. And the thing is, talk to anybody that's part of any of these launches right now, especially through SpaceX. You know, the guy, especially down there in Texas. You know, at at the Starship launch location, Starbase, that is what he calls it. Go talk to those guys. Have a conversation with them. They are some of the most happiest people because they're developing something new. They're building something new. They're developing something new. And when you watch the videos of them seeing this rocket come back and land, they're ecstatic. The thing is what that shows is STEM can still be fun. And so we've pivoted, now away from, the world of bureaucrats to a world where people are inspired. People are wanting to make the challenge. People are wanting to do more STEM work because they're seeing their work come to life. If it's an explosion, it's an explosion. If it's a landing, it's a landing. But you learn something new every single step of the way. Iterative STEM, which now, the thing is as you pivot using iterative STEM from one location to another location, your STEM changes. Your STEM changes. And the thing is also what we're going to see is more kids get interested in STEM because they're seeing these people build these rockets and enjoy what they're doing. So now it's like, hey, I want to go do that. I want to do something that's not like work. I want to go do something where I can have fun and it maybe definitely has some stressful days, some long nights, some early mornings. But I get to watch my creation go orbital. It's kind of different when your creation's going Mach 6. It's one of those things.
So Ford should be, he should be commended and studied because he had the foresight, which he didn't come up with the ideal itself.
Right.
The ideal itself came from the meat packing market, manufacturing in Chicago.
Yeah, I think he came from his grandfather, right?
The process of making a production line.
Yeah.
That came from the meat industry.
Mm-hmm.
He just had the foresight to be able to apply it to something else. Elon Musk had the foresight. He is not the creator of this technology.
Oh, no, definitely not.
He had the foresight. This technology and this technology can go together. And if I put these two together, then I can go here.
Right.
So that's one thing. Now the curse of Ford is Ford, when he made that production model, unfortunately, since Ford's time, early 1900s,
hasn't changed since.
We still have the same management model.
Right.
Which is the reason why the industry hasn't grown. Mm-hmm. And it hasn't grown because they refuse to reinvest into the school systems or the people that they need to maintain this over generations. You can't maintain something over generations if you don't have the people to do it.
Right.
So, and then because it worked this way 50 years ago, doesn't mean it's right.
Exactly.
Doesn't mean it's the most efficient way to do it.
Right.
We use spark plugs today, but maybe someday there will be something where we don't need a spark plug.
Yeah, and the thing is the automotive industry, I think has stepped in this, and it's another conversation I remember hearing, and one that I actually had today, surprisingly. And I'll get to that in here in a second. The automotive industry, unlike the space industry, is stopped asking the question how. They're now living with just do it. Just do the same crap day in, day out, build the same damn ugly thing that you decided to build 6 years ago. We're going to do it again, and we're going to keep rebuilding and regurgitating this model.
And I'm good. I'm good with that part.
Yeah.
If you make it more efficient.
Right. But the thing is no one ever asks, especially in the automotive market, automotive OEM, I'll say it that way. Automotive OEM never asked that question, how, or why, or what can we do better. They always leave those particular questions on the sidelines.
So you know why we have a farmer's almanac?
Yeah, because we want to learn from our mistakes.
Yes, but it's people that gain knowledge by looking at
Right.
multiple things and writing it down.
Right.
And then they kept up with that every year.
Yeah.
And that farmer's almanac, if you look at it, it has the details you need or the recipe you need
Yeah.
to be successful.
And-
And the problem with automotive is they are not doing what the oil industry does. For the last 30 to 50, I say 30 years, the last 30 years, the oil industry has been doing down the hole data.
Right.
They know when something's going to fail.
Yep.
They don't run to failure. They predict to failure.
And the thing is when we study automotive, we're really talking about automotive OEM, because you have the automotive aftermarket, who, like Holley, for example. Holley is making some of the best ECUs on the market. Between them and a couple other guys, are kind of making some of the best
And
ones.
how long has that been going on? But
Yeah.
I just want
Right.
I want to give praise to a company
Holley-
that's been doing it right.
Holley really started going through this process with the Intimidator X model, I think it was, of ECUs. About 5 years ago, they really started getting back into it. However, you have like Link ECU, you have a couple other ones out there who are. We just watched a thing off of DDE today where they were wiring in the ECU, and you have so much data in these race cars and these drag cars, these performance cars you put on the street, that if you don't take into account this data, or the down the hole data in automotive, you cannot make your design better. And that is where we have the issue, and this is where I kind of had this conversation earlier. The reason why the automotive industry is the way it is and looks the way it does, gray, is because of the fact that the cars are no longer made by car people. The cars aren't designed by a car guy. Because if the car was designed by a car guy, it would be easy to work on, it would be affordable, and you'd have data to tell you when something's about to break. Because why? As a car guy, we don't like fixing it. However, we're going to make it look good, but you're going to have more data at your fingertips that you can just plug your laptop into and look in. And the thing is you have all this, the Dominator ECUs from Holley and stuff like that. You can plug a laptop into it and pull up all the data. You can go on their on their ECU command screen and pull up everything that's going on. You can pull up you can pull up pressures for everything. And you can see this all in link diagrams, stuff happening all day long. But the thing is what do we not see? Like you said, the automotive OEM has not changed or advanced or adapted to this particular change of something that came out many years ago. So now we're going to do over-the-air updates. Okay, Dingy, you invented an in-car Wi-Fi. Cool. What are you, AT&T?
And you also made a attack surface,
right?
That can be that can be.
Anybody remember Lucid?
Yeah, I'm just saying, it's not a smart thing to do.
Right. And the thing is why I said, do you remember Lucid? They all went to the same street and bricked themselves. Yeah. So it happens.
Yeah.
But the thing is like you said, it's a tax service. And, while the rest of us are, okay, cool, let me just go plug in my OBD2 reader, and go from there. Cool. I can program it on my phone, here, let me hook you up to my laptop, and then you pipe into my laptop to do the tune while I'm on the dyno. Cool, done. Right? After that, you don't get to touch it.
So the problem that happened with most of these cars, okay, they didn't have a windshield. We put a windshield in it.
Right.
Oh, well now We didn't think that plate glass was dangerous to put in there, so somebody was smart enough to put the right type of glass in.
Yeah, the safety glass. Right.
Or safety glass. All right, then we said, hey, maybe we need windshield wipers. And somebody said, hey, that's useful. Let's do windshield wipers.
Yep.
Now all we care about is, hey, the lights can change on the inside of the dash. Hey, I can watch a video. Hey, I can do Wi-Fi. Stupid stuff. So to me, I have no problem with people want to be entertained. That's fine.
Yeah.
But that's not what the automotive industry started on.
No.
We're not here for lipstick on a pig.
Right. And the thing is also it's a lot about, and you can understand. We always know how and why a STEM person was not involved with certain things. Because now they're trying to figure out the cheapest way to make these cars to charge the most amount of money for it. While somebody involved in STEM looks at it and goes, "We can't do that because we need all this information to make sure we produce this thing correctly the first time. Then we can speed it up afterwards in iterative design." And you don't get that. Now it's, hey, let me break this 15 times and produce one. Okay. That makes sense. But, a lot of things really have kind of went downhill. But then again, it turns into, where are we at in the industry? The industry is just, and we talk about STEM changes and STEM advancements in certain things. The STEM advancements are not in the automotive OEM. They're not there. Maybe in some companies, like maybe Lamborghini, Ferrari, the companies who can pay for it.
What are they, what are they advancing? I'm saying, what has changed?
I'll say
the
this:
last 20 years with cars that's different from. I mean, they got tires, they roll.
Well,
other than the little fancy bells and whistles we got in the car, maybe some safety stuff. Now, I will give them this: the safety I think has gotten a lot better.
Yeah,
anti-brakes and stuff like that. Yes.
But the thing is, so your automotive aftermarket has really spearheaded the STEM change when it came down to ECU design and stuff like that. They spearheaded that. They're spearheading the use of 3D printers and 3D scanners and stuff like that for automotive design, making hot rods. Go read Hot Rod Magazine. They did a great article on that, actually. But you start looking at companies, Ferrari, Lamborghini, Porsche. You start looking at, they're OEM to an extent. Lamborghini and Ferrari are very bespoke manufacturers. They don't produce a lot of vehicles per year. So they have more money to spend on, certain things. It's the same thing as like McLaren. McLaren, what they figured out is, hey, I've got an IndyCar team and I got an F1 team. So we take that technology and roll it into the McLaren, into now the M1. It was they still have the P1, which is the first ever hypercar that is a hybrid. Now you have these guys, like Ferrari and Lamborghini. Lamborghini is really the better one for it. That has made another version of a hypercar that is a plug-in hybrid. So they've taken the hybrid technology currently and turned it on its head. Originally, it was not designed for. It's designed for, hey, how many miles per gallon can you get, right? So they turn it on its head where, hey, let me get the butt dyno involved, and let me have some fun. Let me remember what miles per mile are. Let me, and the thing is Lamborghini really did it right because the vehicle you can turn the motor on. However, the vehicle will run under battery power until the motor is at operating temperature before the motor will kick in to recharge the battery. To save wear parts, to save bearings, to save oil pressure and stuff like that. And it's monitoring all these things in real time. It's monitoring all your corners. It's monitoring how these cars are built. Because the thing is, you got the guys from Ferrari and Lamborghini, but then you have the Porsche guys who makes the GT3 RS, the bespoke cars, the fast cars from them, who take all the racing heritage and throw it into a car and say, well, here we go. Now we're going to put all this technology, all of this advancement into these cars to build factory race cars and factory race street cars. And so they take all of this monitoring data and turn around and say, cool, let's make something. And then if you go to the dealer with one of these cars, or if you even look it up on your own, via your own OBD2 reader, you can see all of the sensors that pop up and kind of tell you, hey, this is what's going on.
I guess.
But what I do not get, you don't have any other OEMs, even though they have plenty of money to do it, step in and say, hey, guess what? We're putting this many sensors in your car, that aren't going to break in 15 minutes.
Yeah.
I get it. We all love AC Delco. Really love them, right? They're cheap. They're going to break. So, yeah. But the thing is you have companies who have race teams who are finally applying race technology, aka automotive aftermarket, to the production market.
Yeah. I guess for me, to me that still is. Yeah, okay, it's a gimmick. All this stuff with this hybrid and all this stuff with the battery stuff, until they come up with a true energy source, all that other stuff is a gimmick.
Yeah.
I'm just saying from
Yeah.
that point of view. Now I do like the ability for the systems to know to switch over. That's pretty ingenious. I just for me, I just hadn't really seen any. Look at it took SpaceX to almost push NASA to being irrelevant.
Yeah.
Before NASA said, "Hey, we better change what we're doing."
Right. It's the old guy way of things. The white hair
I think the
scientist.
same thing's going to have to happen to the.
Yeah, I agree with you.
automotive.
And the thing is now you got these guys in the automotive aftermarket yet again, firing up their brains, taking and making nuclear diamonds from nuclear e-waste and turning those into car batteries. And the thing is these car batteries last 30, 40 years.
Yeah.
But the thing is everybody goes, oh, it's nuclear. Y'all, the material in your watch or your radar detector is worse than that, in larger doses. Because, for example, my uncle works around nuclear radiation all the time, right? Or my cousin, I should say. And I asked him about it. I said, here, read this article for me. Let me know what you think. Tell me about the isotopes and stuff like that. And I didn't read it. He goes, oh, is it enclosed? I said, yeah. He goes, cool, you're safe. He goes, you can actually protect yourself from that radiation. You can pick it up with your bare hands, as long as it's wrapped in aluminum foil.
Or some type of shielding.
Yeah.
But we still don't know the long-term effects of anything that produces radiation.
Right, exactly.
Which by the natural process of the planet, you're getting radiation anyway.
Right.
Via the rays from the sun, via the magnetic fields you're exposed to.
We used to eat off iridium iridium plates.
I'm just saying, like, we're getting dosages. We just don't know what there's not enough data to assess what it does to the body. And what I think happens, our bodies are probably the most sophisticated machine on this planet. And our bodies have figured out a way to adapt to the radiation levels.
Yeah.
Some kind of way.
Yeah. They're also really good at filtering out beer. Yeah. But
in my opinion, I think that
but and I think that we're getting kind of close, but we can continue the thought. I don't really mind. Is the fact that I think as STEM advances, as STEM changes, we've hit. I don't think we've hit peak yet.
I think we just now in the valley.
Yeah.
I don't
even know if we've hit the valley yet.
You're in the dawn of. I don't say done. I think we having a resurrection of things that were done back when we were trying to get to space. I think we're getting back to that type of.
Yep.
I think we're getting back to when we were trying to go to space, where people were excited about science.
I agree with you. I think we're in the question phase. I think we're heading down. We're about to hit that valley, like you said, to start the forward climb up.
Yeah.
Which is good, because then we'll start seeing more U.S. manufacturing pop up. We'll see more resilience on people wanting to go to your local trade schools. We're going to see people want to go to career colleges and stuff like that. And the thing is, and I'll say it right now, one of the big pushes that I have doing my doctorate right now, and one of the things that I really want that I'm going to be looking at, is the use of robotics and 3D printing to keep kids interested in STEM education going across the board, because we want to see, or I want to see, will it impact people's career goals, later in life. If I show somebody a 3D printer one day and I show somebody a robot the next, what do they want to get into? Are they now interested? If I pull them in the classroom the following year, will they be more interested to get there? One of those things.
I think it's up to the.
It's up to the individual.
Well, no, I mean, yeah, that's true too. But I think it's up to the, the generation after the Zers and the.
Yeah.
I think as those kids become more and more interested, and then they expose their kids to those type of things, and we don't get so fascinated with social media and the things that come with social media,
Yep.
and we start to use our brain cells again and quit doing the swipe of death, where we just swiping at funny videos.
Yep.
Maybe it will be a day where somebody says, "Hey, how about I make something?
Yeah.
How about I become a maker?"
Mm-hmm. And the thing is I know people who teach some of the newer generation, and they said finally we're getting kids who understand what sarcasm is again. So we've got kids who aren't interested in being on social media. They watch YouTube, but they don't care about constantly being involved in TikTok. Mm-hmm. I think we're leaving the TikTok generation behind, hopefully. Which the good thing is, the TikTok generation made a lot of people a lot of money. You get to learn a little bit of things, get to express your creativity, which is an art, which is part of STEM. However, maybe not the greatest use of it. But the thing is, it is what it is. And it is up to the individual. It's up to the individual to ride the wave, to ride the STEM wave. It's, if we're going up the mountain, we're getting ready to start the downhill, finish the downhill climb to go up. It's get on now, because it's gonna be a wild ride to the other side. And the thing is like you said earlier, if this upward climb doesn't force a company to change, they're gone.
Yeah, people think it's not a catchphrase. No. Data is the new oil.
Yep.
If you are not able to understand what's going to happen in the future before it happens, in relationship to your company, in relationship to the product that comes into your company, in relationship to the raw goods that you turn into a material to sell.
Yep.
If you cannot realize that and learn how to maximize things, someone is going to someone's going to outperform you, and they're going to put you out of business, or they're going to consume you. I mean, it's going to happen.
Yeah, I agree with that.
And we're getting close to the end, but I like to just say this about social media. I am not against social media. Mm-hmm. Without social media, we wouldn't be able to, talk to you guys from different countries over a podcast.
Yeah.
I mean, I remember when I was a kid, we could do this with ham radio and talk to other people, but they had to have the skills to be able to use that equipment. So, I mean, it's a good thing. I just think we should celebrate more of the sharing of knowledge, as opposed to looking at funny videos.
And the thing is here's what I want. I'm going to make sure, like, the last video did not make it to YouTube. I'm going to make sure I upload that one too when this one goes out. Make sure you go in there. If you're listening to this on YouTube, which I know some people do, some people don't. If you don't, go take a look at our YouTube channel. Subscribe to it. Leave a note on there. What STEM or STEM creator you watch or you're involved in, or if you have your own channel, put it on there. Let us know where you're at, because we want to follow what you do, as well as you follow what we do. Because the thing is we have people right now. I'm looking at the statistics. We got people from from here in the U.S., Brazil, Canada, Australia, Mexico, and Singapore. And, let us know what y'all are doing. But and the thing is I think that kind of brings us to the end this week. Especially when we're starting to talk about, ending this on the social media side is make sure that, if you are in social media and you are doing that, be safe, protect your passwords, protect your loved ones, don't give into the bullying or anything like that. Do it right. Learn something, teach something, enjoy something. be part of this, be part of the STEM revolution, be part of the change, influence change. Ask the question why, or how, and how come. Those questions are ones that we need answered. Those are the questions that we're interested in seeing answered. But I just want to say thank you. We were trying so hard to cross over the 3,000 listener mark. We've passed it now by a little bit. We're at 3,143 all-time listeners. Y'all, we cannot be happier. Go take a look at, vulcanara.com. Go take a look at our website. Go take a look at some of the stuff with, some of the stuff that we have on social media. Vulcanara Tech on some things. Go take a look at Printed Heritage, Vulcanara 3D, where you see some of the merch, some of the t-shirts. We are going to be releasing some limited, I wouldn't say limited, some shirts and some other stuff, probably via the TikTok shop also, and also on Vulcanara 3D. Some stemware, we'll call it, some stem shirts and stuff like that. Go take a look at those. We are going to be at the SEMA show towards the beginning of November. The 4th through the 10th we'll be in Las Vegas, Nevada. It'll be myself and Tim. So we'll be there on the floor, kind of walking around, kind of, looking at the STEM stuff going on out there. If you see us and you're out there in Las Vegas, hit us up, let us know you're there. And, we'd love to have a conversation with you. But, from my side, I say thank you. And I hope y'all are well. Please stay well. If you're in the U.S. and you're in North Carolina or in Florida, we hope that you didn't get impacted by the storms. I know that we're getting into wintertime soon. So, do what you can to stay warm if you are impacted in those zones. So, I want to say thank you, and I'll turn you over to Ed.
Yeah, I'd just like to say I appreciate all the support. Been away for a little bit, trying to take care of some personal things. Life happens, so sometimes you just have to take care of things outside of some of the things you love to do to make sure that your loved ones are okay. But everything's okay. But what I would like to also ask you guys, we're open to, any suggestions, any topics you guys want to talk about. We're still trying to figure out the logistics so we can do like a live stream with you guys and just have a Q&A and you guys ask questions, we answer the questions. Or maybe we just have like a small forum and we just kind of just talk about, what's the state of the industry, or maybe we can talk about some emerging technologies that we are interested in and things like that. But as Nick said, we do appreciate all the support. Like I said, we started this as, just something me and Nick was always doing when we went to have happy hour sometimes, just kind of, spitballing, and it grew into something great. I think this is just the beginning, and thank you for all your support.
Yep. All right, y'all. You have a good one. Bye. That's all for this episode of Tech at Lunch. Thanks for tuning in and joining us for this tech-filled lunch break. We hope you enjoyed the show, and don't forget to subscribe on all channels. And also, you can find us on YouTube under Vulcanara Technology Solutions. And join us for our next episode, which gets published every Wednesday at 8 a.m. All right, y'all. Have a good one. See you later.